Hi, thank you very much for inviting me today. It's a real privilege to be here. And today I'm going to be talking about the changes to glaciers that are happening all around the world, but particularly in the Andes. So glaciers, actually, they cover about 10% of our Earth's land surface, but they actually include an astonishing 2/3 of Earth's fresh water. That's the only water we can drink. And that means they're a really vital water resource in mountain regions. They store up water when it's cold and wet, and they release it when it's warm and dry, periods of scarcity when we really need it the most. Today, I'm going to talk about two particular glacier regions in the Andes from some research projects I've been doing over the last 5 years with Peruvian colleagues and Chilean colleagues. So we're going to go to the ice fields of Patagonia in Chile in a temperate environment, and then we're going to the Cordillera Blanca of Peru and look at some of the tropical glaciers in that region and what's happening to them, but what existential threats they pose to water in the region. First, I'm going to talk a bit about the climate of this region and what's happening to it. So what we have here are some graphs of what's happening to air temperature and precipitation over the last 2,000 years. And what you can very clearly see in the two regions I'm going to talk about in Peru and in Patagonia is we see trends of strong warming, and in some regions we see drying. And so those climatic trends, which are driven by greenhouse gas emissions, so anthropogenic emissions, that's double trouble for glaciers. So glacier health, glaciers form when there's too much snow and less melting. So the snow builds up, it forms ice, and that glacier flows down the landscape. And we talk about glacier health as something called glacier mass balance, which you can think of a bit like your bank account. So the snowfall is the money in, and the melting or loss of icebergs off the front is money out. So if a glacier is having more melting than snowfall, then it's in the red and it's an unhealthy glacier, and it starts to shrink. If we look across the Andes, all the way across the coast of South America, we find that glaciers are now largely in the red. They're not doing very well in terms of their glacier bank accounts. So if you see this graph here, these red bars are the amount of mass of ice that's being lost off these glaciers every year, from 2 meters a year in Patagonia, right up to smaller amounts in the tropical Andes of Peru, but still substantial amounts. And compared to 20 years ago, where actually some of these glaciers were doing okay, they're pretty much now all largely retreating and melting across the region. This is Pastoruri Glacier in Peru, where you can see from the 1980s to 30 years later, very dramatic reductions in area of that glacier. It's lost about 50% of its area. And those are trends which are mirrored across many of the glaciers of the Andes. But what does that mean for water? And it's important for water because glaciers provide us with this nice steady meltwater supply during dry seasons or during summers. And the important thing here is we've got a graph at the bottom which shows glacier loss on the bottom. And then if you follow this line, this is water availability. And in the early stages of melting and kind of warming, you actually have more meltwater going into rivers up to a point where they get peak water because you've got faster melting rates. But as the glaciers get smaller, they can't sustain that meltwater flow to rivers. And so we then go down a declining curve. Now, Patagonian glaciers are still pretty much on this rising part of the curve. The amount of water coming off those glaciers is increasing as they're warming and melt rates go up. The Peruvian glaciers on the right here, they're in the opposite part of that curve. They've reached such a small size now that the river flows are decreasing as a result of the shrinkage of the glaciers. But what I'm really interested in is not just how much water there is, but what's the quality of that water? How good is it to drink? How good is it to have on your croplands, your farmlands? Or how good is it for perhaps the fjord ecosystems and the lakes that sit around glaciers? And I'm going to go to these two glacier domains here. Firstly, Chile and Patagonia, the ice fields of Chile, and then to the Cordillera Blanca, where we have very different things going on, which is largely to do with the fact these glaciers are retreating over very different types of rock. So in southern Patagonia in Chile, this is the results of a NERC and CONICET funded project joint with Chilean researchers called Pisces. And this is a story of fertility, really. So Patagonia has a whole intricate network of fjords. The glaciers sit on this very hard rock called the Patagonian batholith, which is old magmatic rock that used to come up from the centre of the earth. And I was lucky enough to drive the whole way down the Carretera Austral in Chile and sample 30 or so rivers draining from catchments with different amounts of glacier cover in them. Everything from no glaciers in some of these river catchments to 70+% glacier cover. And these glaciers and the rainwaters that feed into the rivers, those rivers nourish and feed water into the very immensely diverse Patagonian fjords, which are very biodiverse. I hope you have several UNESCO reserves around Patagonian fjords. They're hotspots for productivity and have very high biodiversity, so very important to Chile. And what's actually feeding those fjords or helping support those really biodiverse ecosystems are these tiny plant-like creatures that drift in the surface fjord waters called the phytoplankton. And they use light to take carbon dioxide out of the atmosphere to grow, and then larger things eat them, all the way up to fish and larger organisms. And so as we were driving down this river transit, we were able to sample rivers from everything in areas where there weren't any glaciers. So this is a river here from a non-glaciated region. You see it's very clear. It's probably got lots of organic carbon in it coming off the forested watershed sides here. To glacier catchments, to river catchments with large amounts of ice. And this is the Rio Nef here in Chile and Patagonia. You can see that river is very cloudy, and that's from all the sediment eroded from the bottom of the glacier. So you can see how rivers coming from catchments with lots of glaciers versus not lots of glaciers are really different in terms of the water they put into fjords. And what we're going from is a situation that looks a bit like the middle picture to one that might look a bit like the one on the bottom left as we take the glaciers away. But what does that mean for the fjords? So these rivers, they're really important in supplying the nutrition for these freely drifting plant-like organisms called the phytoplankton. And I'm just going to talk about two nutrients that come from the rivers. One is silicon, and silicon helps build the walls of these phytoplankton called diatoms. They have these really intricate sort of almost glass shells that they use to protect themselves. And a lot of that silicon comes from rivers. I'm also going to talk about iron, which is a micronutrient for phytoplankton. And these things help the phytoplankton to grow and then help support the food webs. And what we were able to do from this immense journey from the north to the south of Patagonia, sampling all these rivers from different catchments with different amounts of glacier cover, is we were able to look at what happens as you shrink the amount of ice in the catchment to the sediment and the nutrients going into the fjord. So what we've got here is the amount of glacier cover on the bottom of these graph axes, and then we've got the yield of the nutrient or sediment per kilometre squared of the catchment on the long side here. And what you can very clearly see is if you reduce the glacier cover in these catchments, the sediment loading of the rivers goes down. Now, that might be a good thing for our phytoplankton in the fjords because those waters are clearer, they contain less sediments, and actually it enables the phytoplankton to get to the light and be productive. But if you look at these two nutrients, silica and iron, you can see that actually as you retreat the ice, it looks like we have a reduction in the amount of the nutrients going from those rivers into the fjord. So a reduction in supply of nutrients to the phytoplankton. So what we've got here is a kind of an existential threat to the really diverse and productive ecosystems of Patagonian fjords, because we're changing what's going into them. We're changing the fresh waters, we're changing the sediments, we're changing the nutrients, and that will absolutely have an impact on the kind of the structure of those ecosystems and their productivity. So that's what happens in Patagonia. But I'm now going to flip north, right up to the Cordillera Blanca of Peru, where I've been working on a Newton-funded project with Peruvian researchers. It's called Cascada. And here we have a very different story. This is a story of toxicity, and it's a story which really affects the livelihoods of thousands of people across this region. Peru has about 70% of the Earth's tropical glaciers, and as you can imagine, the tropics isn't a great place for glaciers to be. So what we have here is very different. Here, the glaciers are sitting on very different rocks. They actually override these old sediments that used to be at the bottom of the ocean. They're Jurassic sediments, 150 million years old, and you can see them here in the forefields. They're rust red. They're actually have a very high content of metals in the rocks. And the glaciers grind up those rocks as they move. This is one example of one of the river catchments, and you can immediately see the exposure of these Jurassic sedimentary rocks by this rust red landscape. And the glacier in this case is retreating back over those rocks and exposing them to rainwater and meltwater, and it causes them to dissolve. And as they dissolve, they release acidity and metals into the water. That compares with this catchment here, which is a very different type of catchment. The glacier hasn't retreated back over those metal-rich rocks yet, and it's a much more pristine-looking catchment. And the problem we've got with that situation is that some of the rivers now in this region have become highly acidic from the retreat of the glaciers over those rocks. This is just a graph when we drove the whole way down the Rio Santa River Basin, where you've got about 250,000 people. And these coloured circles indicate the acidity of the river waters in that region. And you can see the orange circles here. This is where the rocks are very acidic. They're about the same acidity as your stomach. So they're becoming toxic. What we also find is that when you go to the front of these toxic river catchments, you find very high concentrations of metals in the waters coming out of the glaciers. You can see the rust red staining on the landscape here. And so what we have is a situation where you've got acidic waters retreating glaciers, and metals are being released from the glaciers into the waters. Here you've got a lake in front of Shayap Glacier in the Cordillera Blanca. It's a very dark green colour, and that's because of the high concentrations of potentially toxic metals, things like copper, things like lead. These are some of the concentrations of those elements we find in the waters, and lead on the bottom here, the red dots are where you've got high concentrations of lead, and these are not good waters to drink. So what do we do about this problem? We've got two very different situations here in Chile and Peru. And we've got, situation in Patagonia where you've got fertility issues in fjords, and you've got a situation in Peru where the retreating glaciers are causing toxicity in the river waters. What's the solution? Well, the thing driving these trends are greenhouse gas emissions and how that's affecting our climate and therefore glacier retreat. You can see these two graphs on the top here for the Andes and also low latitudes, which cover the two areas I'm talking about. And we're looking at very substantial losses of glaciers over the next century. But you can see different lines. They represent different pathways by which we might follow with our emissions and therefore global climate. And you can see there's some very big differences depending on whether we drastically cut emissions like the blue line, or we carry on in an unabated fashion. So it really does make a difference to our glaciers and these water supply issues and the potential issues for ecosystems, what we do with our emissions. But you can also see that over the next few decades, we are going to get substantial glacier loss almost regardless of what pathway we follow, that those changes are locked in. And that means that the communities in these regions and that the governments and the local authorities managing water resources in these regions need to help us adapt. And what we've got here on the bottom is just a picture of some wetlands in the Cordillera Blanca in the bottom of the valleys. And the incredible thing about these wetlands is you can see the pampas grasses there and some other vegetation. And those plants are able to take up metals naturally from the waters. They're able to purify the waters. They're called hyperaccumulating plants. And what we've started to do through our Cascada project is that we're about to go back into Peru in next month. We started to work with local communities to see how we can take those natural solutions happening in the landscape and create artificial wetlands, direct the water through the wetlands. We plant the plants, they take up the metals from the water. We have some lime in there to reduce the acidity, which provides the communities ways in which they can start to purify their own water and take control of the situation. My colleague in Peru, Raúl Loaiza Muro, he's also been developing an app that these communities can use, where the communities can look at, people can look at what's in the water in terms of the little organisms, and the organisms have different tolerances to acidity and metal toxicity. So depending on what's there, they can start to say something about how clean their waters are and how good they are to drink. So there is hope. There are hopes on sort of small local scales for what we can do, but that, you know, the overall problem is one of climate warming and requires a global solution. So lastly today, just some take-home messages. Glaciers are far more than just water stores. They erode and dissolve their rocks. What's in the rocks enters the rivers. It impacts ecosystems, everything from fjords, rivers and lakes. It also impacts mountain communities. And the solution to these problems, you have to come at this from both ends. We require global strategies to reduce greenhouse gas emissions, but we also require local action to help us adapt and help people who are quite vulnerable and dependent on glacier water resources in the mountains to actually kind of enable them to live with those existential risks. And if any of the stories you've enjoyed today in my talk, I also have written about this in the book that we talked about earlier. The book is called Ice Rivers, and there's a whole chapter on Patagonia and also the changes in the Peruvian Andes. And it's very much a story of glaciers, people and wilderness in a time of change. Thank you ever so much for listening.